So the first example, the electrical resistance of a wire varies directly as its length and inversely as the square of its diameter. If the resistance of 100 meters of wire having a diameter of 3 centimeters is 0.21 ohms, what is the approximate resistance of 50 meters of this wire with a diameter of 4 centimeters? So it's a very wordy problem. And when you're looking at these problems, first off, the one thing that should stand out is you see the word varies. When you see the word varies, automatically it's a variation problem. So I'm going to start with my steps, and the first thing I'm going to do is put brackets around my question. So the question says, what is the approximate resistance of 50 meters of this wire with a diameter of 4 centimeters? So bracket my question. Okay, after I bracket my question, I'm going to circle all the numbers that I see in this problem. So I see 100. I see 3.21 ohms and 50 meters and 4 centimeters. Okay, so now that I've circled all the numbers, it says any of the numbers that are in the question need to be written down in step 4. So step 1, 2, 3, 4. So within that question, I've got 50 meters and I have 4 centimeters. So these are numbers that I'm going to use in step 4. So I have remaining 3 numbers, which tells me that I'm going to have 3 variables in this problem. 100, 3, and 0.21. So each of these numbers has to have an assigned variable. So that's where I'm going to get my variation rule. So if you remember the other day, I said when you see the word varies, you immediately want to write down equals K. So what equals K? So the electrical resistance of a wire varies directly with its length and inversely as the square of its diameter. That sentence is where I get my variation rule. So resistance varies directly with its length and inversely, remember the word inversely means divide, as the square of its diameter. R equals KL divided by the square of its diameter, so D squared. So that's it, step 1. Step 1, I have my variation rule. So now the numbers is what I need to use next. So I have the numbers 100, 3, and 0.21. So if the resistance of 100 meters of wire having a diameter of 3 centimeters is 0.21 ohms. Okay, so you got to think, I've got units attached here. So what goes where? So 100 meters has to do with length. So my 100 goes with my L. Then it says having a diameter of 3. So 3 is my D, which leaves the 0.21 ohms. Ohms has to do with resistance. So there's my R. So I'm going to set it up. 0.21 is equal to K times 100 over 3 squared. So now I need to find K. So I'm going to start off by getting rid of this division. So anytime I have division, to undo division, I use multiplication. So I'm going to multiply 0.21 times 3 squared. And when I do that, I get, so 0.21 times 9. So I get 1.89. So I have 1.89 equals 100K. So then divide by 100. So 1.89 divided by 100 is 0.0189. So K is equal to 0.0189. So step 3, write your function rule. So my function rule is R equals 0.0189 L over D squared. So R, L, and D are my changing variables, and my constant, the one thing that doesn't change, is the 0.0189. So now we're ready to answer the question. So step 4. So now this is where we're going to use the 50 and the 4. So the question wants to know the approximate resistance. So R is what we're trying to find. So what is the approximate resistance if 50 meters, so 50 is my L, of this wire with a diameter of 4 centimeters? So 4 is my D. So I set it up. R is equal to 0.0189 times 50 divided by 4 squared. So plug that into your calculator, and when you do, your resistance is 0.059. So that's how you take a pretty intimidating problem and you break it down one step at a time with the 4-step process to answer the final question. So take the time, please complete the U-Try, follow your 4 steps. When you're ready, watch the video to see how you did.